Alright, you might recall in our last video we talked about the vertical asymptote. So in this video we're going to talk about horizontal asymptote. These are super easy. In the case of a horizontal asymptote, we want to see what's happened to the value of a function as x increases without bound or goes to infinity, or decreases and goes to negative infinity. In pre-cal last year you called this the end behavior of a function. So let's define what a horizontal asymptote is. Simply put, a horizontal asymptote is defined as any time we take the limit as we go to infinity. Because what we want to find out is what's happening to the behavior of the function as x goes to infinity. Are we approaching a horizontal line? Are we approaching a slanted line? Are we approaching some weird shape? There is a shortcut for this, and this is what we're going to take a look at. We're going to see what we're going to look at is we are going to use what matters the most. And the reason for that is very simple. If we were to look at this first function right here, as x gets really, really large, and I'm talking very large, if we look at this x squared right here, it starts to matter a lot more than this x. For example, if I have 1, they're both the same. 1 and 1 squared is still 1. But as x gets larger, like let's say 10, well this becomes 30, this is now 300. As x becomes like 100, there's 300. And this starts getting way, 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 way bigger. So in the big scheme of things, on the numerator, we say what matters really the most is this 3x squared. Everything else we can just ignore as x gets really large. Because we're seeing is what happens as x gets really large, not nearby. On the bottom, the 4x to the 4th is what matters the most, not the 3. So I could rewrite this. The limit, as x goes to infinity, 3x squared over 4x to the 4th. And this is really nice. I can just simplify that. We get the limit as x goes to infinity. Please don't plug in infinity. Don't do this. Yo, Mr. Wernell, can I do this? Don't. No. No, bad math, bad math. Don't do that. But I can reduce it. This becomes 3 over 4x squared. And now we're going to define another rule for us. In the horizontal, we said what happens as we get really, really, really close to dividing by 0, and we said approaches infinity. Well, this one says, well, what happens if we're dividing by infinity? Well, we get 1 over infinity, which is phenomenally huge. This is approaching 0 for us. And that's really helpful. Because if I were to plug this infinity in, I would get 3 over infinity. And my rule now says that's just going to become 0. So we have a horizontal asymptote at 0 right there. And that's how we actually define it. So remember pre-cal last year you learned if it's big on bottom, it's 0? Well, now we know why. We're taking the limit process. So let's try number 2 real quick. If I look at what matters the most, I'm not really interested in the 1 or the 5x or the 3. When I rewrite this, the limit as x goes to negative infinity, we're going to get 4x over 2x squared. And again, I'm going to simplify this. The limit as x goes to negative infinity. And if I reduce the x's here, we're going to get 4 over 2x. If you want to make that 2 over x, you're fine too. And if I plug this in, this becomes 4 over negative infinity. Well, don't really panic. I mean, it's the same thing. I'm still dividing by a really large number. And that, of course, becomes 0. So in pre-cal last year, you would say there's a horizontal asymptote at y equals 0. In other words, as x gets really large, as x goes really, really large, the function here is approaching 0. So something kind of like that. So let's try number 5. Okay, so for a problem like number 5, well, what really matters the most on the top is this 5x cubed, and on the bottom is that 3x cubed. Remember, as x goes to infinity, we're looking at what's happening as x gets really large, so I don't care about the others. And I can rewrite this. The limit, don't forget to rewrite the limit every time. 5x cubed over 3x cubed. X cubes cancel, and what are we left with? Yeah, 5/3. Very simple. And in pre-cal last year, you would say there's a horizontal asymptote at y equals 5/3. Now, it's interesting. Remember last year in pre-cal, you said if the ratio were the same, if the degrees were the same, you would just look at that ratio right there, which is what we're doing. All right. Here's the hard ones right now. So let's take a look at number 4. Well, when we start considering about, again, as we go to infinity, so when we start considering what matters the most, on the top of this one, we have 2x over the square root of x squared plus minus 3. We really only care about that 2x. So this becomes the limit as x goes to infinity. The top stays 2x. On the bottom, I don't care about that minus 3, so I'm left with the square root of x squared. All right, everybody, this is where the fun begins. So let's recall what the square root of x squared is. It is the absolute value of x, which is, for us, plus or minus x. So if I leave this as plus or minus x, let's see what happens. We get 2x over plus or minus x. Now, we can't have two answers here, so we have to decide which one we want. To that, look at what the limit says. This is literally saying x is positive. We're going to a positive infinity, so I picked the positive one. And I'm going to go ahead and write out this one more step here. The limit as x goes to infinity, 2x over x, x's will cancel, and we're left with 2. So easy. A mathematician, a senior in May can do this one. So let's take a look at number 5. So for number 5, we look at the same thing. Now be careful, this time we're going to actually negative infinity. We still only want the 2x on top. So when I rewrite this, I only want the 2x on top. The bottom, be careful. I'm still going to keep that 3, but I only want, the other part is the square root of x squared right there. Now, recall, we know what the square root of x is. It's going to become plus or minus x. So this is going to give us 2x over 3 times, and this plus or minus x right there. Whoops. Remember, though, I did mess up. That was a negative infinity, and it will make a difference because this time we want this to be negative x. So this time we're going to pick this negative x right there. And if I were to rewrite it, just to make it, just to kind of clean it up, we get 2x over 3 times negative x right there. The x's will cancel, and that's going to become negative 2/3. If this was going to positive infinity, we would have positive 2/3. This is a really interesting looking graph. It almost looks like a tic-tac-toe board. All right, so let's have some fun. All right. What happens if we have a problem like number 6 here? So let's take a look here. If I look at what matters the most, I got this 3x squared and this x down here. That's all I really care about. Now, if you're really good, you can simplify it. This becomes 3x over x, or just 3x squared. I don't care about the rest. I'm just going to simplify that. Now, if I were to plug in infinity, this becomes 3 times infinity squared, which is, yeah, just infinity. So we're going to say this equals positive infinity. Now, a lot of times people ask, do we have to put positive infinity? No, you don't have to. I just do. And that's how we work this one. What if we're approaching a negative infinity? Well, it would still be positive because we're squaring it. So let's see. Now, in pre-cal last year, you learned that the degree on top was larger than the degree on bottom. You called this an oblique asymptote. And what this is really saying is, as x gets really large, the function looks like the parabola 3x squared. And that's going to go up on both sides. So it's going to approach infinity. And it should make sense. A parabola, as we go on forever, just keeps growing. All right, number 7. Again, all I care about is the 3x squared and the 5x. So if I were to rewrite that as x goes to infinity, this just becomes 3x over 5. So solving it, plugging in, we're going to get, and if you want to, 3/5 times infinity. We don't ever like to write this, but we think it. And yeah, 3 times infinity is just infinity right there. There we go. See, I didn't put the positive infinity in that one. So let's take a look this time now. We're going to go to a negative infinity. All I care about is, because I'm going to infinity, all I care about is what matters the most. Everything else can just go away. So we get the limit as x goes to negative infinity. And if I simplify it, we get 3/7 x. Plug in the negative infinity, we get 3/7 times negative infinity. That's just negative infinity. There's our answer. Notice I'm not putting the negative infinity here, right? I'm not circling that one because, not on AP. You don't like those, okay? We don't like to say we can multiply infinity by anything because you can't. All right, next one. So let's see here. If I were to simplify this one, cancel, cancel, cancel. All I care about is those. It's like cancel culture. We get the limit as x goes to infinity. This becomes 7 over 4, and again, I'm really left with x squared. That's easy enough to do. 7/4 times positive infinity squared. Yeah, that's just positive infinity right there. All right, let's take a look at a question like number 10. We've seen this before up top. We only care about this bit right there and this bit right here. So we get the limit as x goes to infinity. This becomes the square root of 3x squared over negative 2x. Now I can simplify this a little bit as x goes to positive infinity. The square root of 3 times plus or minus x all over negative 2x. And recall, the only one we want is the positive infinity, so we only want the positive x here. So I'm going to show another step here real quick. The limit as x goes to infinity, this becomes the square root of 3 times x over negative 2 times x, right? X's cancel, and we get negative root 3 over 2. And real quickly, try number 11. Take a pause and try number 11. We want that. We want that. We get the limit as x goes to negative infinity. The square root of 3. We already don't reinvent the wheel here. This is just the square root of 3 times plus or minus x all over negative 2x. But this time, remember, we want the negative x. So I picked the negative there. And we're going to get the limit as x goes to negative infinity, root 3, negative x over negative 2x. X's cancel. 2 negatives will make a positive, and we get positive root 3 over 2. All right, hope you enjoyed the videos. I will see you guys later. Have a great day. See you next time.